Good morning, students. Welcome to video lecturing class on control engineering. Today we'll discuss about analysis of multiple input and multiple output systems. So for whatever the problems we have solved on block diagram, there is to have only one input and one output. But in some of the systems, it is necessary to have multiple input and multiple output, or two inputs single output, or two outputs single input, depending upon the requirement is to design the block diagram in such a way that you can have the multiple input and multiple output signals. So for such cases we can use the law of superposition, that is considering each input separately while assuming the other inputs as 0. Most of the times, if only input is applied to the summing point is to be removed if it is not necessary, because as we have seen in the previous block diagrams, there is to have all the inputs at the summing point. So in such cases, if there are more than one input, we can suppress that summing point by inserting the proper block with the proper transfer function. So now this can be achieved by introducing a block of transfer function -1 in series with that signal. That transfer function of -1, if it is the signal is with negative sign, if it is with positive sign, that time you have to introduce a block with +1 as the transfer function. And you need to remember this step, because the transfer function of the inserting the block, whether you have to take it as +1 or -1, it depends upon the sign of the signal at the summing point. So we'll try to solve some of the problems on this multiple input and multiple output systems. So here this is the given problem. For the block diagram shown, find the output C due to R and disturbance D. So here we are going to write R here, and we are having R. R is the input and this D is the disturbance additional input. So it is a system in which you are having two inputs and single output. So now in such cases, first you need to consider any one of the input. So in first case I will consider R as the input and I will suppress that D as the negative, so that I can have single input and single output system. So now I will consider this D as 0. So once you consider this D as 0, directly you cannot eliminate this summing point, because at this summing point you are having another signals which are coming here and the output signal. So in such cases you cannot eliminate the summing point, you can just ignore this input. So first case, consider R and D as 0. In that case your block diagram will become like this. That is, here I have ignored or I have eliminated that another input D. Now in this we are having, you can see here, this can be a canonical loop. That is, in forward path we are having G3, and in feedback path we are having H1, one summing point and one takeoff point. So we can consider this one as the canonical form. Similarly here G1 is there in forward path and this is a takeoff point, and here you don't have any feedback block, but it is a signal. Whenever in these kind of cases, that is, if there is no block, you have to assume that there is a block with a transfer function as 1. Okay, nothing means there is a block, or the signal value of that transfer function is 1. So it is also forming a canonical loop here. So for these two canonical form, you can write the transfer function directly. That is, for this the transfer function will be G1 divided by 1 plus, here I have taken positive sign because here we are having negative, G1 into 1, because here the transfer function of this feedback block is 1. G2 as it is, then this is forming the canonical loop. So it is G3 divided by 1 plus G3 into H1. Again here I have taken plus sign because we are having here negative sign. So now if you see these three are in series, so you can replace these three blocks by a single block by writing the transfer function as a product of the individual blocks transfer function. So it will be G1 G2 G3 divided by 1 plus G1 into 1 plus G3 into H1. So now it is forming a canonical loop here, one block in forward and one block in feedback. So can write C by R as, that is output by input, as in the numerator this function G1 G2 G3 divided by 1 plus G1 into 1 plus G3 into H1 plus G1 G2 G3 into H2. It is like if you take this one as a G, this one as H, it is 1 divided G divided by 1 plus G into H. Through this simplification you will get the transfer function as this one. Then moving further, case number 2, here I will consider D as the input and I will eliminate R and carry the negative sign of the H2. So here if you see the given problem, if I want to eliminate this, so at this summing point only one input and one output will be there. So I will eliminate this summing point by introducing a block of transfer function minus 1, because this is with negative sign. Okay, if it is with positive sign, that time you have to replace with a block whose transfer function will be 1. So here I have replaced that and I am considering this one. So now if you look at this, so this is forming the canonical loop and this is also forming the canonical loop. Write the transfer function. Now if you see, here is the input and this is going to be the output. This is the forward path and the signal which is coming to this summing point from here is going to be the feedback path. You see here, this is going to be feedback path, and if you observe that all these 4 blocks are in series, so directly you can write the product of their individual transfer function. So I will be getting as, this is in forward path as it is. In feedback path you are having 4 blocks, write their product, you will get it as minus G1 G2 H2 divided by 1 plus G1. Now if you look into the block diagram, this block is in forward path and this block is in feedback path. So in the numerator G3 divided by 1 plus G3 into H1 divided by 1 minus written here, because here it is with plus sign, 1 minus numerator as it is into transfer function of this block. If you simplify this, you will get R by D as G3 into 1 plus G1 divided by 1 plus G1 plus G3 H1 plus G1 G3 H1 plus G1 G2 G3 H2 is the transfer function. Now moving further, the second problem. Obtain the expressions for C1 and C2 for the given multiple input and multiple output systems. So here if you look at that block diagram, there are 2 inputs and 2 outputs. So in such cases you need to consider one input and one output at once, and you have to ignore the remaining input and outputs. So first I will consider R1 as the input and I will ignore R2, and C2 is suppressed. I will consider C1 as the output. So in that case your block diagram will be, so I am eliminating this and I am suppressing this C2. So your block diagram will be like this: R1 as it is, G1, C1 as it is. Here this contains a summing point here. At this summing point you are having one more input, but when I make this R2 as 0, I have to replace this summing point by a block of transfer function minus 1 because this signal is with negative sign. So minus 1 G2 remaining things as it is, you have to draw. Now if you look into the block diagram, so this is going to be the forward path and this is the takeoff signal which is in feedback path. That is, from here it will start, it will cover G2, sorry G3, minus 1, G2, G4 and it is fed to the starting summing point. So in forward path you are having only one block, that is G1, and in feedback path you are having 4 blocks which are in series combination. So for those series combination you can write the product as G2, G3, G4 into minus 1 because this is also in series. Now if you look into this block diagram, so it is forming the canonical loop. So directly you can write the transfer function, that is in the numerator transfer function of this block divided by 1 plus, because here it is minus, transfer function of this block G1 into transfer function of this block minus G2, G3, G4. So we will be getting transfer function as G1 divided by 1 minus G1, G2, G3, G4, that is C1 by R1. Similarly, considering the second case, now we will try to get C2 by R. That means we are considering R2 as 0 and we are suppressing C1. So in such case, R1 as it is, G1. So here we are suppressing that C1. From there, it is a G2. We are eliminating R2, that is the reason I introduced the minus 1 block here, G2, and you have to consider this C2, then G4 as it is fed to the summing point. Now if you look into the forward path, start from input to the summing point, then it is fed to G1, G3, minus 1 block, G2, then it is output. So that means in forward path you are having G1, G3, minus 1 and G2, and here you are having the takeoff signal and which is acting as a feedback path. So G4 and fed to the starting summing point. That means in forward path G1, G3, minus 1, G2, and in feedback path it is only G4. So write the product, it is minus G1, G2, G3, and in the feedback you are having only G4. So now it is forming the canonical loop. So write the canonical form equation, that is C2 by R1 equal to minus G1, G2, G3 divided by 1 plus, because here it is minus, numerator term as it is into this term, that is transfer function of a block which is in feedback path G4. So this is going to be the transfer function, that is C2 by R1. Now for the third case, we will eliminate R1 and C2 is suppressed. That means to get the transfer function as C1 by R2. So in such case, when you are going to eliminate that starting input, so it is having a summing point there in which one of the signal is with negative sign. So I have introduced a block with minus sign here. Okay, R2 as it is, C2 is suppressed. So here you are having the input and it is fed to G2, G4, minus 1 and G1, then output. That means this is the forward path. Okay, and this is the feedback signal or takeoff signal which is covering G3 and it is fed to the starting summing point. So these 4 are in series, write the transfer function, and G3 is in feedback which is forming the canonical loop. That means again it is forming the canonical loop in which in forward path you are having transfer function as this and in feedback you are having transfer function as this. Now write the transfer function as C1 by R1. In the numerator, transfer function of the block which is in forward path divided by 1 plus, because here you are having minus. In the denominator 1 plus transfer function of both the blocks G1, G2, G4 with negative sign into G3. So this is going to be the transfer function, that is C1 by R1 when R1 is eliminated and C2 is suppressed. Now for the fourth case, we are having C2 by R2. That means eliminating R1 and C1 is suppressed now. So again, for elimination of R1, I need to introduce a block whose transfer function is -1, and here I am considering C2 as the output. I am suppressed C1. So now if you look into the block diagram, so it is R2 fed to G2 and C2 is the output. So this is the forward path here. Near to this output, you are having a takeoff signal which is covering G4, -1, G1, G3 and back to the starting summing point. That means in forward path you are having only one block, that is G2. In feedback path you are having 4 blocks as G4, -1, G1 and G3. So you can replace these 4 blocks by writing the product of their individual transfer function with a single block. So that is R2 is the input, G2 is the transfer function of a block which is in forward path, C2 is the output, and for this takeoff signal the transfer function is -G1, G3, G4. Now if you look into this, again it is forming the canonical loop. So C2 by R2 will be in the numerator the term transfer function of the block which is in forward path, G2 divided by 1 plus, here it is plus because it is having minus sign, numerator as it is, into the transfer function of a block which is in feedback path, -G1, G2, sorry G1, G3, G4. So the final transfer function is C2 by R2 equal to G2 by 1 minus G1, G2, G3, G4. So here, while solving the multiple input and multiple output systems, you have to consider only one input and one output at a time, and you have to suppress the remaining inputs and outputs. So you have to eliminate the inputs. While eliminating, you have to check, that is, here you need to check whether it is having only one input or more than one. If it is having more than one input, at that time you cannot directly eliminate this summing point. You have to replace this summing point by a block whose transfer function is 1, and a sign you have to decide based on the sign of this signal. If it is with minus, you have to replace with a -1 block. If it is with plus, you have to replace with a +1 block. And then you need to carefully observe which is the forward path and which is the feedback path. Based on that, you will get the series combinations. Finally, you will get the canonical form, and you have to write the transfer function for that canonical loop. So these are the problems on multiple input and multiple output systems. So with this, we will conclude the block diagram reduction. So in the next class, we will start with the signal flow graphs. If you are having any queries, you can leave the comment in the comment box. Thank you.